Right, welcome back. So we are doing the second test. It's geometry, measures, and mensuration. This is also a test that you can use to prepare yourselves for your examinations. The diagram shows the cross section of a metal presentation. So we're supposed to show that x, this distance here, and that distance there is equal to 150. Now, let's look at this distance that we have all the way, say that distance up to there. Do you agree that that distance should equal to 480? Okay, so if you see that that's the case, then we can equate all of those distances with the unknowns to 480. So that means I can say, wait a minute, 180 plus x should give me 480. So this is an equation that's 180 plus 2x, an equation in terms of x, and if I can solve for x, then I can prove that x is equal to 150. Okay, so that will be 2x equals to 480 take away 180. Okay, and then x will be 480 take away 180, that's 300, divide by 2, and therefore x is equal to 150. Right, they want us to find the perimeter of the cross section. So before we do anything, we've got all the distances. We now know that this distance here is 150 centimeters. That one is also 150 centimeters, but we missed this distance here. So the whole thing is 50, okay, and this distance here is 20. So that means that this distance here will be 30, okay. Similarly, this is 30, so the whole thing should be all the way up to 50. So that distance there should be 20. Now you simply grab your calculator and then you add those distances together. Okay, so I know this is also going to be, I'm just going to write them down. So I'm going to say 150 plus 20. So I'm going in clockwise direction, plus 180 plus 150 plus 20 plus 480 plus 30. Okay, okay, did I miss anything? 20 is 480, okay, plus 30. So I went. That's good. That's a nice thing about always making sure maybe you have missed something. So 150 plus 20 plus 180. Aha, I didn't add this 30 here. Okay, so you can see when I had that 180 there, let's say plus 30 plus 150. Okay, plus 150 plus 20, that's 20 here, and plus 480. Okay, and plus that 30 that goes up there. Okay, if I hit enter, it's 1060. So the perimeter is 1060. 1060. Okay. They are now asking us to calculate the area of the cross section. Well, I'm probably going to divide this thing into rectangles. So I'm going to have this. So I have three rectangles there. Don't know if you can see. So let's check in blue. So this rectangle here, the area of this rectangle here is going to be 150 times 30. 150 times 30. That's my first one. This one here is 180 times 50. This one here is 150 times 20. Now that's a 20 there. Okay, and then I'm simply going to add up those areas. Okay, in blue. So let's see. Grabbing out my calculator, I have 150 multiply that by 30. That gives me 4,500. Then next one, I have 180 times 50 is 9,000. Okay, so that's 9,000 over there. The next one there, or the last one there, is going to be 150 times 20. Well, that's 3,000. Okay, right. So I'm now going to add the areas of those sort of rectangles. Okay, in order for me to find what is the area of the shape. So we say 3,000 plus 9,000 plus 4,500. Okay, 16,500. So we say 50,500 or 16,500. Okay, so I said the area of that, I had 180 times 50, then I had 150 times 30, and then I had 150 times 20. Okay, that gives me this value. Part C, the platform is a prism, so you have to find the width, or prism, the width is 170 centimeters. Now the volume is the area of the cross section, so the volume is the area of cross section, which we determined in the previous answer, 16,500. So 16,500 cross section. We multiply that by, let's say, the width, doesn't matter, or the length. So multiply that simply by 170. So this is the square centimeters times centimeter. Here will give us the, square cubic centimeter. But remember, so multiply our answer there by 170. So our answer is 2,805,000. So that's 2,805,000. But this is cubic centimeter, okay? That was centimeter and that was centimeter square. Our answer should be in cubic meters. So let's just see, what does 1 cubic meter actually mean? It means 1 meter times 1 meter times 1 meter. And what is a meter? Well, a meter in terms of centimeter is 100 centimeters times 100 centimeters times 100 centimeters. So in essence, 1 cubic meter is equal to something with 6 zeros, that is a million cubic centimeter. So in order to change our answer, we'll have to divide this here by a million, okay? So we just simply divide by 1 million, okay? It's 2.805. So that's 2.805. Okay. The second question. The diagram shows a prism of length 12 centimeters. The cross section is a regular hexagon. We need to find the total surface area. So what I've done here, okay, I have opened, this is the net, we call this the net, okay, when you open up this sort of prism. So this is the net, and when you look at the net, you have 1, 2, 3, 4, 5, 6 rectangles, and those rectangles, they have got, if we have to find the area of those rectangles, it will be 12 times 4. Do you agree? So that's 12 times 4. Okay, so this will be 6 times 48. Okay, if we were to calculate 12 times 4 being 48. So once you calculate that and you multiply that by 6, so that will be 288 square centimeter. So these are the areas of this rectangle. So we need to find the area of this and the area of that, and we add it to that, so to speak. Okay, now how do we find the area of that? So we're gonna go, all right, if you're too fast, please remember you can always pause and so on. So I'm going to take the cross section here. What I'm going to do is I'm going to draw, let's use red, or even that, doesn't matter. I'm going to draw a diagonal, a line like from there to there, okay? And do the same maybe from here to there, and do the same from here to there. So what I'm now realizing is that I'm having 6, okay, triangles, identical triangles. And all these triangles, they have, remember this distance here is 4, that is 4, and so on. So all these distances are the same. Here's the thing, we have got 6 angles here. So each one of these angles must be 60 degrees. Do you agree? And if that is the case, then the interior angles of triangle all add up to 180. So this, what we have in fact, is we have got 6 equilateral triangles. Right, so that distance there is 4 and that distance there is 4 as well. So we can actually calculate the area of one triangle. Okay, so if we find the area of one triangle, we have an angle, we have a side 4, we can use our formula to calculate the area of a triangle. And then we're going to multiply that by 6 because we've got 6 such triangles. Okay, and then we add our answer to 288. Okay, so I'm going to say that 288, I'm going to add it because I'm looking for the total surface area. So 288 plus 6 times, now here's the formula, the area of a triangle is a half times 4 times 4 times the sine of 60 degrees. Okay, all of this is going to give me the total surface area. So that's 288 plus, let's grab our calculator. So we've got 6, well, times a half, I can say, just put it up like that, doesn't matter, times 4 times 4 times the sine of 60 degrees, which is a irrational number, so I'm going to have an answer with some square root stuff. All right, in any case, it is 41.56 41.56 921 is right down a full calculator display, 92138. Right, so we are just going to add that, and if I add that to 288, so I'm going to say plus 288, well, that gives you 329. Okay, all right, so that's 329.5691, and so on and so on. Okay, now you can go ahead and give your answer to 3 significant figures, and to 3 significant figures the answer will be 330 square centimeters. Okay, so initially this question did not have the net, okay, and also did not have that. So the only thing that was given was basically just that. And so I thought, let me just bring in more diagrams to help you to answer that question. Right, it continues though. Water flows through a cylindrical pipe of radius 0.74 centimeters, and it fills a 12 bucket. Wonder if I did not skip a point. Okay, yeah, a 12-liter bucket in 4 minutes. Okay, so let's see. B Roman 1. Okay, and B Roman 2 will be something else. B Roman 1. Okay, now we need to be able to calculate the speed, and that's centimeters per minute, of the water through the pipe. Okay, right. This is a little bit of a tricky question, but I wrote down the information that we need. We know that this is a cylinder, the radius is 0.74. It's given to us. We need to be able to remember the volume that is here, the 12 liters, is the same 12 liters that flows through the pipe. So in essence, the volume of what is in the pipe, is going to equal to the volume of what goes into the bucket, which everything is equal to 12 liters. Okay, that is something that I need you to get to grasp before we continue with anything else. Also, what we need to know is that 12,000, let's just bring it in black. Okay, so let's say 12 liters is also equal to 12,000 milliliter, which is equal to 12,000 cubic centimeter. I hope you understand and know the relationship, right, between the capacity and volume. Okay, so basically 1 milliliter is the same as 1 cubic centimeter. That is something that you need to know. So what I did is I changed the liters to milliliters, and then I know now, because I have the volume of the pipe. Now remember, the volume of the pipe is a cylinder, so the volume of the pipe is like pi r squared times, let's say, the length. That is why I indicated here the length. That should equal the volume of the pipe, which is 12,000 cubic centimeters. Right, so in any case, we need to find the length of that. So in order for us to find the length of that, we are going to say, because remember, this is the cross section of that. All right, so we're going to say the length of that, we're going to say the length of the pipe will be 12,000 divided by, because you see The radius is in centimeters. That is why we had to change everything to centimeters. So that is 0.74 squared times pi. Okay, that is going to give us the length. So let us see what that length is equal to, the length of the pipe. So it's 12,000. Divide that by, okay, let's see if we can change our calculator so I can just have my fraction the way I wish to have my fraction. Okay. Let's clear everything. I'm going to clear everything. Okay, clear everything. The calculator. Press all clear. All right, now I have it as I want it. So it's 12,000 over, in brackets perhaps, you don't have to put it in brackets, but you can go ahead and put it in brackets if you want to. 0.74 squared times pi. I don't have to put the times there. Calculator will automatically do it. So the length of the pipe is 697538. I'm going to write that down. Okay, so it's 6975.380997 centimeters. Okay, because I want you to realize that this is the area divided by the volume. Okay, do not round your answers as we go along. Only do the answer towards the end because you don't want premature rounding. So what does speed indicate? Speed is the distance divided by time. So what is the distance? This distance is 6,975.380997. So that's the distance. That's how long the pipe is. And what is the time? Well, we are told this is done in 4 minutes. So the speed can now be calculated. So we take that answer, we simply divide it by 4. Okay, 1,743 and some more. So it's 1,743.8452 and 49. So this is centimeters per minute. Right. So we're basically done. You just now go ahead and you write that answer to 3 significant figures. So it's 1740. That is to 3 significant figures. Okay. All right. So it's a handful. I gave you a hint there, and please follow that hint so that you'll be able to solve such a question. No, it's complex, but you read the question and you do some conversion and maximize your chances of getting marks there. When the 12-liter bucket is emptied into a circular pool, okay, the water rises by 5 millimeter. Okay, problem. We know that the 12 liters, which is equal to 12,000 cubic centimeters, so it will be best if we can write 5 millimeters by dividing it by 10 as centimeters. Okay, right. What do we know? We know because we need to find the radius of the pool. So the radius of the pool. So we say that volume, this 12,000, which is pi r square times h, should give me 12,000. Okay, the pool is circular form, so circle, so circular volume of that. So we're going to have pi, and our radius is given as 0.5. No, our radius is what we are supposed to calculate. So we're going to say pi times, okay, right. So I'm going to save. I'm going to come back to this. An error occurred, okay, because I pressed something on my pen, but I'll just come back to the paper. Maybe you can also take a breather or so. So let's just open it again. I just did something on my stylus when I was writing with it. Okay, so let's restore and go back to our word. Okay, good. So the radius is what we're looking for. So I'm going to say r squared then. So let me just take this pi away. So I'm going to have r squared is equal to 12,000. Well, we're going to divide it by the height, which is 0.5, the level of water depth, multiply that by pi. And once we have that answer, we're going to take the square root of that answer because we're looking for the radius, okay, of the pool, correct, to the nearest centimeter. Right, so let's bring our calculator in, and we're going to have 12, of course, let me go step by step, 12,000 divided by 0.5 pi. I get 7,600 and something, 39, all right? And then in order for me to get R alone, I'm going to take the square root of this answer on my calculator, okay? So I'm just going to say square root of answer, and that gives you 87.4 and so on. So it's 87.4038, 7445, 7445 centimeters. Now the question says you must give your answer to the nearest centimeter. So to the nearest centimeter, this answer is simply 87. Okay, right. So step by step, a lot of work, but eventually you will get there. Right, question 3. A solid metal cone has a base radius of 9 centimeters, a vertical height of 24 centimeters. Now you're supposed to calculate the volume. Right, so with the grade 11, so just make sure that the formula is correctly given to you. This formula will be given to you in the exam, okay? It's a third pi r square times h. So the volume will be 1/3 times pi times the radius of 9 squared times the height of 24. So we just go ahead and we plug that in onto our calculator. So it's 1/3 times pi times 9 times 9, so 81, times 24. Okay, and I'm going to write that answer. So it's 648 pi. But of course, you can also go ahead and write your answer, 2035. If you don't want to leave your answer in terms of pi, so 2035 point, well, we have got point 75204, 75204. Okay, right, 1, 2, 3. So you can leave your answer as 2040, okay, or to the nearest. Okay, I'll go to the nearest, so it's 2036 to the nearest volume. Anything within that range, okay, it's totally acceptable. A cone of height 8 centimeters is removed by cutting parallel to the base, leaving the solid called a frustum. This is a frustum shown below. We're now supposed to show the volume. Let's find out what is the volume of this frustum. Okay, I've done the same stuff under here. So we know the volume of the cone. So the volume of this cone, we've calculated it before. I'm just going to write it. This volume is 648 pi. I'm just writing in terms of pi because I don't want to write that long one, okay? We know we can actually calculate or determine, we need to find what is the volume of the small one, okay? So the volume of this one, so let's calculate what is the volume of that one. Why? I'm going to take the volume of this cone here and I'm going to subtract it to the volume of the small cone over there in order for me to find the volume of the frustum. But I don't have a radius here. So I can't be using the formula to find the volume of the smaller cone. So that is not going to help me in any form or shape or whatsoever. So what is it that we need to do? We have to use similarity. Similarity because this cone and that one on top are similar. That's a smaller version of that. So let's compare the given sides. So we know that if I look at it, the side, the short one, it has now a height of 8 and the other one has a height of 24. All right, essentially this is going to give me my constant that I'm going to work with. So let me just simplify this so you can see. So it's going to be a third. So 8.24, that gives you a third. All right, so that's a third. So we need to compare volumes. So what am I going to do? I'm going to say, well, this 1 over 3, if you cube it, let's say we're going to take the volume of the small one that we don't know over the volume of the big one. Okay, so I have to take the volume of the sides that I'm cubing because I'm using volume. So this is like 1 upon 27 equals to x over 648 times pi. Right, so I'll do cross multiplication and then I'll find the volume of x. So in order for me to find the volume of x, I'll have 27x is equal to 648 pi. Therefore, x will be 648 pi divided by 27. So I'm going to get what my answer is giving, my calculator is giving me. All right, so it's 648 pi, okay, shift pi. I'm going to divide that by 27. I'm still going to leave my answer in terms of pi, okay? So this is 24 pi. So this is the volume. This is the volume of the smaller cone. Right, so how do you find the volume of the frustum? The volume of the frustum is calculated by saying volume of that solid frustum is the volume of the big cone, which is 648 pi, take away the volume of the smaller cone, which is 24 pi. Okay, so let's go. 648 pi minus 24 pi. Okay, 648 shift pi minus 24 shift pi. That gives me 624. 624 pi. What is that equal to? Okay, so that's 1960 point. So it's 1960.353816. 353816. All right, but what does the question say? We're supposed to prove this answer correct to 3 significant figures. So when you go back and you look at 3 significant figures, 1960 cubic centimeters. So to 3 significant figures, of course, it is 1960 cubic centimeters to 3 significant figures. So that is why you would see that I do not do premature rounding so that it doesn't affect my answer. And I was using pi, so I don't have to write down those horrible long numbers that I got for my previous answers and stuff like that. Okay, so that is how you look at that question. So part C, the 1960 cubic centimeters of metal in the solid in part B is melted and then it is made into 5 identical cylinders, right? So 5 cylinders. Now I know that the volume of a cylinder is pi r square, and here we are told the length is, so I'm going to write length here first, and that should equal to 1960. So that's like 5, and then you have pi r squared times 15 equals to 1960. Of course, I can say r square is going to be 1960 divided by 5 times 15 times pi. And whatever that answer is, I'm going to take the square root of that answer. Okay, and then I hope you understand why I use the 5 here. Okay, so please don't get confused. The 5 is indicating the 5 identical cylinders. Okay, so you can find the volume of one cylinder and then you divide the final answer there by 5. Doesn't matter. Okay, just have to be careful. All right, so let's see what our radius is equal to. So again, you go, we say, well, I'll use my answer, which is still what I have, 1960. I'm going to divide that answer by 5 times 15 times pi. Okay, I made a small mistake there. So 5 times 15 times shift pi. Good. Right, so I get something like that. Okay, 8.32. So you get 8.32. If you now take that answer and you take, so let's say r square is equal to 8.32. Then r is going to be the square root of 8.32, the positive one, okay? It's the distance. So the square root of my answer then, it's something like 2.88, blah, blah, blah. So it's 2.88, go again, 44102 centimeters. Okay, so what is this now to one decimal place? Because they say we are supposed to give our answers to one decimal place, and to one decimal place, r therefore is equal to 2.9 centimeters to one decimal place, which is what we're supposed to prove. Okay, so please, reading from, or if you went through my first video on matrices, vectors, and transformations, I also indicate to you how you can access this question paper. All right. You can obviously, as I said, you will see that I'm uploading that. And once the videos are uploaded, then you will see a description where I put, so I'm going to go, for example, to my Google Classroom, okay, and you can download this icon onto any of your devices. So Google Classroom over here, and if you then go to my grade 11 or even grade 10 class, because I share the two classes, all right, so grade 10, grade 11, for you to join my classes, this is the class code to join my classes, MYA3DO. Reason, you can actually go and download this question paper. So it is it's a PDF document with 3 tests, and the test that I'm indicating to you, where I did the first one was on matrices. Also check it out. And then the next one, this one that I'm doing, is on geometry, measures and mensuration. This is the one that I just did, okay? And the next one that I'm going to do is also on the same document, is probability and statistics. So you go ahead then and you print out and download the paper for yourselves in order for you to prepare for your exams and also for your studies, even if you're a teacher. So again, you can go there. So you go to Google Classroom, or you download Google Classroom, okay? And let me see, I just want to get the link. I've got different classes here, so the link to this particular document. So I'm just going to copy the link, and since I'm uploading the other one, I said check out my link to my Google Classroom, okay? So the link there, taking you directly to this video, to this document. You just click on that link and it will take you to that document, okay? Also, perhaps I can also put, so for those of you who want to know how to join the classes, you can say, I will say the code to my grade 11 Google Classroom is given by the following. So let's just go ahead and go copy that code. So the code is, okay, so that's the code MY, let's copy it, MYA, right? Let's go there, so paste. So again, that's the code if they ask you to join in order for you. So I'm nearly done uploading this one. The next one I'm going to upload is going to be the one on geometry. So also stand by then for the next video. The next video after this is going to be based on statistics and probability.